qua và Dean sẽ giới thiệu qua một chút về những cái bài học của ngày hôm nay. Hi Dean, yeah. Hi Dean.
Hi, morning.
Yeah, morning. We can start. Can you summary for yesterday and showing what PDF we can start today?
Sure. Let me share my screen here.
Okay. Thank you.
Okay. So welcome back, everyone. Thanks for joining again. So yesterday we covered 4 workshops. Today we've got 3 workshops, but the 3 today are a bit more in-depth than some of the ones yesterday. So yesterday we started with the very simple importing of just the pipes and the junctions, and then we went and fixed it up by morphing some elements and then putting some settings into those elements, so a pump curve and some PRV settings and of course tank elevations, reservoir elevation. And then the modelling fundamentals, where we learned how to draw a network out from scratch using the layout tools. So that's important. If you need to add anything to your existing network, you need to know how to use the drawing tools. And then of course the valving in critical segments, which I think is we have a lot of features in WaterGEMS, which of course you can see in the analysis tab, but criticality is one of the best, and the reason I think it's one of the best is because it's very, very simple and quick to use, but you also get a lot of fantastic information out of it. So if you have the valves in your network, in your GIS, or maybe already in your model, then all you really need to do is open up criticality and click compute. So it's very, very simple, and it takes no time at all. So that's why it's such a good feature, because there's very little setup and there's very little information required. And we have the tools there, as I showed you yesterday with the assign isolation valves to pipes tool to do it automatically. So that yesterday was kind of an introduction. And then today we get to some of the more in-depth ones, as I said. So the first one's going to be the EPS modelling, number 8 here. And what we're going to do with that is take a steady state model, so a model that just runs one time step, and then we're going to do all of the work required to take it from that one time step through to a 24-hour full day simulation with everything that comes with that. So a diurnal pattern, as well as some pump on and off controls, which are very important, and then we'll try a couple of different scenarios, and we'll even compare the costs of those different scenarios as well. So you'll see the way they work differently. We'll also have a look at some graphs and stuff like that, some color coding, and so you get a better idea of what a fully built 24-hour model will look like in terms of not only building it but also the results. So yesterday we didn't graph anything because they were all just one time step. Now, of course, we can graph things. So that's the plan for today. Fine, are we all ready to go and get started on the workshops?
Yes, thank you. We can start now.
Excellent. Okay, so if we go back into WaterGEMS, see I've still got mine open from yesterday, so if you've still got it open, just go ahead and close the criticality. And then come up to open here, and the one that we want is EPS. Go ahead and open up EPS. So as you can see, we've got an existing model here, but like I said, this is just a steady state model. So what we need to do is put everything in to make it into an extended period simulation. If you're wondering what EPS stands for, extended period simulation. So in our case, it's going to be 24 hours, but it can be as long as you like. So you could do 1 minute or 1 hour or 1 day or a week or several days or whatever you want. So there's no limit on that time that you want for the extended period simulation. Okay, so the first thing we need to do is put a pattern in, because of course the demand changes throughout the day. So you just come over to the Home tab, and then on the Home tab next to the Demand Control Center, you'll find the patterns. So go ahead and open up patterns. Okay, so up the top with hydraulic selected, go ahead and click New. And that'll create hydraulic pattern 1, which we want to rename diurnal. Then, of course, we need to enter the values here from 0 to 24 hours. So the first thing we need to do is change the starting multiplier, which is 0.8. The pattern format is continuous. And by the way, all patterns, if they're from a flow meter or from a graph of any any kind of transducer or meter that you've got, they'll always be continuous. Okay, so we need to copy down the values here. So from 3 down to 24. And then we need to put the multipliers in. I'll just give you a minute to put those in.
Yes, 1 minute.
Sure.
Yeah. Yes, sending. Okay. Yeah.
Okay.
Yeah.
Excellent. So keep in mind that we've created the pattern, but we also need to assign the pattern. So if you close down the patterns, just because you've created it doesn't mean that it's doing anything. So we need to go up to the Demand Center, Demand Control Center. And you'll see that we do have demands here, but we don't have the pattern. So all we need to do is right click in the top and global edit, and then set the pattern to diurnal. Of course, all junctions have the same pattern. So you can OK that, and of course, all of them should now be diurnal. Okay, close that down. And now we just want to check on our pumps to make sure that our pumps are ready to go for an extended period run. So up right underneath the patterns, pump definitions. So you can see that both pumps have been created here. So pump 4 and pump 5, which are in our model, and both of which have a pump curve. What we need to do though is put the efficiency in. So if you go to the efficiency tab, see at the moment it's just a constant efficiency of 100. You want to change that to best efficiency point. Best efficiency point flow is 657.19. The efficiency at that flow is 75%. We also need to go over to the motor tab and tell it that the motor efficiency is 95%. So
Yeah.
that was for the first pump. We need to do the same thing for the second pump. So if you click on the second pump, 95 for the motor. And the efficiency, of course, we need to change again. Best efficiency point, 657.19 and 75. So I'll just give you a minute to put those values in for the second pump.
Yeah, 1 minute. Yeah, 10 okay.
Excellent. Okay, so now, by the way, the reason that we put the efficiencies in is because, as I mentioned, later on we're actually going to do an energy cost analysis on the different scenarios that we create. So that's why we need the pump information in there so that we can run our costings later. Okay, so if you close that, the next thing we need to do, and again it's with the pumps, is make sure that the on and off status is correct for midnight. So if you go to flex tables, pump, so you can see here that it says status initial. Pump 4 is on, pump 5 we want off. And the reason for that is because the start of this simulation is at midnight, and we know from SCADA data or some other source that at midnight only one of the pumps is on. Okay, so once you've done that, close that down, and speaking of the calculation options, that's what we're going to go and create now. So up on the home tab, right here in the first area, options, which is your calculation options. And under steady state EPS, I'm going to create a new one. And what you want to do is rename that 24-hour EPS. Once you've created it and renamed it, double click to open it up, and now we can see where we can go and actually change what type of run that we want to do. Okay, so the most important thing here is, of course, time analysis type. See that it's set to steady state. We want EPS, of course. So you see, once you change it to EPS, you get the midnight start time, 24-hour period, and 1 hour time step. All of that is fine for us. That's all correct. So we don't need to change any of that. We can just close it.
Okay.
All right, now we get to the most important part. So the most important part of any model is the controls. Because if your controls are wrong, or you get the signs around the wrong way, anything like that, your model will not work. As soon as you get a control wrong, you'll get either tanks filling or emptying, and then everyone will run out of water, and then you'll get all sorts of problems. So that's why the controls are so important. If you don't have them correct, then your model will never work. So back over in the common area here with controls. Go ahead and open up controls. The nice thing about the controls in this particular case is that what we're trying to do is control a pump based on the level in a tank. And if you're using only pumps and tanks, then you can use the wizard. And the wizard makes everything much, much easier. So instead of creating the controls manually down here, what we can do is come up to this control wizard icon here, the wand. And if you click on the wand, it will open up the control wizard. Once you're in the control wizard, go ahead and select new. And we're going to do pump 4 first. So pump 4. There's only one tank, so you can only select tank 1.
Yeah.
On operator is less than, which is correct, and the on HGL that we want is 106.7.
Yeah.
Off 109.4. And then, of course, we need to do pump 5. So create a second one for pump 5. Again, there's only one tank. This time we have different levels. 105.2, 108.2. Okay, so like I said, if you use the wizard, it's very, very easy to put in these controls. So all we need to do basically is type in the levels that we want the pump to turn on and off at, which we've done. So you can click create. Now, of course, you can read each of the 4 different controls off. So if the hydraulic grade in the tank is less than 106, then turn pump 4 on. If it's greater than 109, then turn it off, and so on. So those are the controls that the wizard's gone and created for us. So obviously, very handy tool, the control wizard. Before we exit the controls, we need to put those 4 controls into a alternative so that we can tell the scenario what we want to do with turning things on and off, because we are going to do a separate one later. So to do that, you come up to this Control Sets Manager button here. Go ahead and click Control Sets Manager. You get this error. Would you like to add a new control set? Yes, I would. And I'm going to call this Tank Controls. And click OK. So what it's done is it's created a control set for us called Tank Controls, and now what it's doing is it's asking us, well, which ones do you want to use? And we want to use all 4. So I'm going to tick all 4 controls on. Of course, when we make extra controls later, we need to make sure that we tick the correct ones on and off. But for now, we want all of them.
Okay.
Yeah, exactly. Click OK. And then you can close down the controls. Now what we need to do is take that control set that we just made and put it in an alternative. So if you come down to the left where we docked the alternatives, you'll find that controls has its own alternative called operational. So go ahead and expand operational. You get base operational controls, from which we want to take a new child. This is called Tank Controls. Once you've created Tank Controls, double click to open it up, and then of course just change your control set to Tank Controls. close it down. Now, of course, we've got the alternative as well as the new calculation options. So, of course, we need a new scenario. So if you go to the scenarios and from base, take a new child called tank control. Open up tank control and change, of course, your operational to tank controls. And down the bottom in the steady state calculation options, we need 24-hour EPS.
Yes.
Once you've done that, close it down and make current tank control and then compute. You'll see that this time we get a long list of calculations, and you'll see that they're in time steps 0, 1, 2, 3, 4, and so on. But we also have these extra time steps. So you can see at 24 minutes and 2:45 and 5:19. So if you click on the time step and then go to status messages, it will tell you why. And what it's saying here is the pump was on and then it's off. So because the pump turned off, that was a significant event in our model. Therefore, the model added an extra time step in for us. So even though we only had 1 hour increments, it's added an extra one in because we need to know about that status change. Okay, so if you close down your calculation summary, what we can now do is start to look at graphs. So the first one here, I'm going to click on J1, and then just holding down the control key, J3, J9. So I've got 3 junctions highlighted. Then I can right click anywhere and say graph. See that the scenario is correct. I've got the 3 that I selected and it's set for hydraulic grade here. So that's all correct. So you can click OK. See we've got 3 different pressures for 3 different junctions all on the same axis here. And you'll see that we can add multiple things to the same graph even from different scenarios. So this graph here, the first thing you might want to do is save it and name it. So the thing up the top, you can see that it's just called new graph. I'm going to go all the way over to the left here and use the add to graph manager button. So add to graph manager, and I'm going to call it junction pressures. And then if you OK that, you'll see that we've changed the title of it and we've also saved it. So we can open up this graph anytime we like now. It's now saved into our model. The other thing you might want to do with the graph is make it look different or better. So if you come up to the 4th button along with the drop down next to it, you'll see that we've got series options, chart options, observed data. So the one that we want here is chart options. What you can do in chart options is pretty much everything. So this is where you can change color, change scale, to change pretty much anything you like about how you want this graph to look. So one of the other things you can also do is if you go to the 3D tab, you can make it 3D. So we're not going to go through all of the options as far as what you can do with a graph and all the different things you can make it do in terms of color changes and all that. But if you do want to make any of those changes, then it will be in the chart options. So just keep that in mind. The next thing you might want to do with this graph is you might want to check certain things, like, for example, what's the highest pressure that junction 1 got to here. You can see on the graph it's around about 120, but we're not quite sure. So that's where you can use the data tab. If you go over to the data tab, see that it's all listed here. And then you can export, you can copy this out, you can send this to Excel or whatever, or put it in a report. Or you can just go to junction 1 here and say sort descending, and I can see that at 19 hours my pressure was 120.1. So I can quickly and easily go and sort my my columns to see what was the smallest value, what was the biggest value, all that kind of stuff. Okay. So if you close down the graph, and now we can have a look at the pump, because the reason we want to have a look at the pump, and in particular pump 4 here, is because this is what we wrote the controls for. So we would expect to see pump 4 turning on and off. So I'm just going to go to pump 4 and right click, graph. See that it's flow. Okay, and here you can see the graph for flow. Quite obviously we can see that it is turning on and off throughout the day. So our on and off control levels are obviously working. So we've got an on level and an off level that are obviously correct, because throughout the day we've got the pump turning on and off 5 times. Okay. So that's a scenario with the tank operating, of course. So the tank is filling and emptying, and then our pumps are turning on and off based on the tank. What we're going to do now is we're going to take the tank out of service. So we're going to pretend that this tank doesn't exist and we only have our pumps. Okay, so the first thing is we need to go over to our alternatives. And in active topology, you get base active topology. We'll take a new child, rename that no tank.
Dean Sunit, if you can hold, it's
Sure.
a bit, the translation is not going up with that, please, thanks. Thank you.
Good to go, Sunit?
We'll wait for Paul. Okay, thanks.
Okay, thank. Keep continue. Yeah.
Okay. So no tank here. Just double click on no tank. And of course, we need to go to the tank tab. There's only one tank, and see is active. It's ticked. I'm going to untick it. Which basically means turn it off. Okay, so you'll see in the drawing, we've got the tank here, but we also have pipe 16. So we need to turn off pipe 16, because otherwise pipe 16 will just be open to the air. So we need to go back to the pipe and down to the bottom here, turn off pipe 16. Okay. Once you've turned off pipe 16 and the tank, you can close down that alternative. And now we need new controls, because, of course, we can't control the pumps based on the tank. So we need to write new controls. So go back up to the common area and controls. So what we need to do is write a new condition so that we can apply that condition to our actions, and that will make more sense in a minute. So if you go to the conditions tab, you see we already have 4 conditions. We need to create a new one, and it's new simple. Condition type is element, that's correct. And then what we need to do is go and look for it. So using the binoculars, using the either the binoculars or the mouse, but we use the mouse. And the one that we want is the pipe that's coming out of the reservoir, so pipe 18. So if you click on pipe 18, see that pipe 18 there, and it's automatically said flow, less than, and then a discharge. What we want is greater than. So if the flow is greater than 657.19, then we will commit to an action, and we'll get to the actions in a minute. So make sure it says element pipe 18 flow is greater than 657.19. So we've created the condition. Now we need the action. So if you go to the action tab, we already have 4. So as you can see, 4 already made actions. So all we need to do is assign these actions. We don't need to recreate them, and we don't need to duplicate them. We can just use them as they already are. So to do that, back to the controls tab. And we're going to create a new control.
Yeah.
Okay, so the if condition here, I'm going to find condition. So down here, I'm going to go to the binoculars, find condition. And of course, it's the one that we just created. Go ahead and select that. The then action, so find action. And what I want to do is pump 5 equals on. So if the flow gets greater than that, then turn pump 5 on. Go ahead and select that. But we also need to make sure that the pump is off otherwise. So I'm going to tick this box here, has else. And the has else, again, find an action. And we're finding it because we've already created it. So pump 5 status equals off. So you'll see that we've got an entire control that you can read off here. So if the pipe gets too large for one pump, then turn the second pump on. But otherwise, if it's less than that, then leave pump 5 off. So that's our no tank control. Of course, just like we did with the tank controls, we need to put this into the alternative. So if you go up to the control sets, you see that you can add, remove control sets. We already have one here, tank controls. We need to create a new one, which I'm going to rename no tank. So we've now created that, so that's fine. You can close that. Then go back to the control sets manager. See the tank controls here, and then no tank. So for no tank, you just want to tick on the bottom one. Of course, the other 4 do not apply to no tank, and this flow one does not apply to our tank controls. So they're opposite ticked. And once you've done that, click OK. And you can close down the controls. So we're going to do the same thing as last time. We're going to take the base operational controls, and we'll take a new child called no tank. Same as last time, open it up, change the controls to no tank.
Yes.
Okay. Now we need a scenario to run this. So back to the scenarios. And from base, new child. This is called no tank constant speed. So the constant speed, we haven't changed anything in the pump yet, but we will soon. So that's why we wrote constant speed there. But open it up and change the active topology to no tank. Of course, the operational, you need to change to no tank. And the steady state EPS, of course, we still want to run the 24-hour EPS. Once you've done that, you can make that current. And as soon as you make it current, you should notice that over on the right-hand side with the tank and pipe 16, you should notice that they're now grey. So you can see that they still appear in the model, but they're now grey instead of black, which means that they're turned off. So anything that's grey is turned off in the model, which is, of course, what we want. We want it turned off, so that's correct. You can compute. You see that this time there are no additional time steps because the pump stayed on the entire time. So if you close that down, and now we want to run a graph. So I'm going to get junction 1, hold control, junction 3, junction 9, and graph. So obviously a fairly different graph to the last one because this is just the opposite of our diurnal pattern. So if you close that down, what we'll do is we'll create the next scenario and then we'll go and look at the differences between all three of them. Okay, so over to the alternatives, and this time we want a physical. So from base physical, we'll take a new child, which I'm going to rename variable speed.
Yes.
Back to the scenarios. From no tank constant speed, I'll take a new child, which I'm going to call no tank variable speed. Open up no tank variable speed and change the physical to variable speed. And close it down and make it current. So very important that you make it current because we're going to go and change it in the drawing. So whatever we change in the drawing is going to change the particular scenario with the red tick. So once you've done it, created it, assigned it and made it current, you can double click on pump 4 and open up the properties here. And you'll see if you scroll down to the physical area, is variable speed pump false? We want true. See that it's target head, junction 1, hydraulic grade, and the hydraulic grade target that we want, 115.8. So once you've completed all of that, you can then compute your variable speed scenario. Okay, so this time when we graph it, instead of just graphing it for the variable speed, what I want to do is compare all of them. So I'm going to go to just junction 1 here, and I'm just going to right click and say graph, just as we have been, but this time I'm going to tick on over on the left, tank control, constant speed, variable speed. So I'm going to graph all three scenarios all on the one graph. And hydraulic grade is fine, so click OK. And then you now get a graph with a direct comparison of 3 completely different scenarios. So you can start to see the power of the scenarios and the graphing tools here where we can make informed decisions by graphing all of them compared to each other, rather than just individual graphs that we need to print out and compare or whatever. So to finish off this workshop, what we're going to do is, you can see the different pressures here, but we also need to know the costs.
Yeah.
So I'm going to close down the graph here and over to the analysis tab. So in the analysis tab, you'll find that there's an energy cost folder, and scenario energy cost is the one we want. You go ahead and open up scenario energy cost. Okay, so the first thing we need to do is tell it what costs we need to use. So up to the button next to compute energy pricing. And I'm going to create a new one, and it's called uniform energy price. Time of day, we want changed to constant. So the constant energy price is $0.1 per kilowatt hour. Now, of course, yours might be in different currency, which is fine. That's you can add your own energy price later. Of course, you can make these tariffs as complicated as you like. This is just an example. So once you've created a constant energy price tariff there, you can close that down and come over to the pumps. And the energy pricing, we need to assign. So they both have the same, both pumps have the same cost. And then what we can do is go and compute our energy costs. So go ahead and click compute. Over to the summary, and you'll find that for no tank variable speed, the cost is $729 per day. Of course, we need to compare that to the other ones. So if I compare that to the constant speed, compute, see it's $985 a day. So $250 more expensive for the constant speed compared to the variable speed. And of course, we need to know the tank as well. So you can compare the tank. And the tank's about $50 cheaper than the variable speed pump, because of course the pump turns off for a lot of the day.
Yeah.
Okay, so there was quite a bit in that workshop. Is there any questions? That is the end of the workshop, by the way.
Yeah, thank you. I have a summary for SAWACO for this session.
Sure.
Dạ. Dạ, chào mọi người SAWACO ạ. Em xin tóm tắt lại một chút xíu về cái bài tập vừa rồi Dean vừa thực hành xong. Thì ở bài tập này thì Dean ban đầu sẽ nhập vào một cái mô hình nước, và Dean sẽ thực hiện là phân tích cái mô hình này dựa trên 3 cái kịch bản. Thứ nhất, đó là kịch bản có bơm hoạt động dựa trên cái mức nước của bể chứa. Cái kịch bản thứ hai đó là kịch bản là chúng ta sẽ bỏ bể chứa đi và chỉ có bơm hoạt động thôi. Và cái kịch bản thứ ba là chúng ta thấy là sẽ bơm vẫn hoạt động, không có bể chứa, nhưng mà bơm sẽ có tốc độ biến thiên. Thì sau khi mà phân tích cả ba cái kịch bản này thì Dean show cho chúng ta thấy cái biểu đồ tại J1, J3 và J9 á, thì chúng ta thấy là cái áp suất nó sẽ cao nhất vào cái thời điểm nào trong ngày, tức là tương ứng với lại cái mức mà sử dụng cao của các hộ dân hoặc là của những cái nhu cầu xung quanh những cái mối nối này. Và thứ hai cuối cùng là Dean vừa show cho chúng ta thấy đó là cái hiệu quả năng lượng mà khi chúng ta sử dụng một trong 3 kịch bản này thì cái hiệu quả nào cho cái chi phí giá điện là thấp nhất. Thì Điên vừa kết thúc cái phần bài tập này thì mọi người có câu hỏi nào có thể typing vào cái chat box của Meet của team ạ. Hi Dean.
Yes.
We have a question from Mr. Kwa. Mr. Kwa have question about what is the best senior?
What was that? Sorry.
Sorry, please wait a minute. I will typing in chat box Mr. Kwa question. Như vậy.
Which is the best optimized scenario?
Yeah.
Yeah, so that totally depends on the cost of the tank. So we don't know the cost of the tank in this particular example. So you can't say, but of course you would normally lead towards the variable speed pump because not only is it cheaper, it also provides a better service to the customers.
Yeah. Dạ, hai anh Khoa, bạn Vin vừa trả lời thì ở trong cái kịch bản, ở trong cái bài tập này chúng ta, cái thiếu sót đây là chúng ta chưa có biết cái giá của cái bể. Thì nếu mà ở ngoài thực địa hoặc là từng theo cái khu vực lắp đặt bể thì chúng ta sẽ có cái giá bể ở đây, và dựa trên cái giá mà xây dựng bể đó thì mọi người có thể so sánh chi phí với việc hoạt động bơm thì mới suy ra được là cái nào là hiệu quả nhất. Và trong cái trường hợp này thì Dean thấy là ta thường sẽ sử dụng cái máy bơm biến thiên thì sẽ cho cái hiệu quả tốt hơn và sẽ tăng cái trải nghiệm nhu cầu của khách hàng khi mà cái bơm biến thiên nó sẽ duy trì được cái áp suất cho cái người dùng. Dạ, anh Khoa có ok với câu trả lời của bạn Dean không ạ? Yes, standing, yeah. Any more question? Dạ. Mọi người có câu hỏi nào không ạ? Ngoài anh Khoa ra thì có ai có câu hỏi không ạ? Dạ, cảm ơn anh Khoa vì câu hỏi rất là hay của anh. Dạ, nếu mọi người không có câu hỏi nào thì chắc là chúng ta sẽ tạm giải lao khoảng 15 phút nha. Thì chúng ta sẽ quay lại vào tầm 11 giờ 15 giờ Việt Nam. Hi, Thanh. Yeah, we have no more question, and I think we'll take a break.
Yes.
In 15 minutes. Yeah.
Sure.
No, Thanh Điên. Yeah. Okay. Yeah, hẹn gặp lại mọi người sau 15 phút này.
Thanks, guys.
Thank you. We already to back. Yeah. If you okay. Yeah.
Kwan, Sunit here.
Yeah. Hello, Sunit.
Yeah. My request is, can we ask SAWACO participants, to start this session, what are the projects they are working on? So, we'll have the feel what kind of projects they are working on.
Yeah.
Okay, so at least you can ask them what kind of projects, so we can navigate now next session towards that particularly.
Yeah. Okay.
Please, whether it's a 24/7 supply schemes, or what kind of their priority, is it a water loss management is their priority, please.
Yeah. Bạn Senit vừa
Yeah.
Dạ. Bạn Senit vừa hỏi mọi người là không biết là mọi người có thắc mắc gì về cái session vừa học không, và nếu mọi người có thể ok thì mọi người có thể chia sẻ về một số những cái dự án mà mọi người đang làm, thì những cái chia sẻ đó của mọi người sẽ rất là tốt để định hướng cho người thuyết trình. Dạ, nếu mọi người có chia sẻ nào thì mọi người có thể trao đổi. Dạ, ví dụ như mọi người có đang theo một cái dự án hoặc là đang có một kế hoạch triển khai cho chống thoát nước, hoặc là triển khai mạng nước mới, hoặc là như thế nào đó, mình có thể chia sẻ thêm. Vì WaterGEMS nó có một cái phần gọi là phần phân tích chống thoát nước đó, thì phần này rất là hay. Thì nếu mọi người đang ở trong cái dự án tương tự thì sẽ rất là tốt để chia sẻ thông tin này.
Yeah, Kwan, if not, we are not getting answer, no worries. I think then we will start.
Yeah, okay, yes. Thanks.
We will take offline. Yeah, okay.
Okay,
yeah.
yeah.
Thank you, Dean.
Yeah, rồi.
Please.
Yeah, Heidi. Yeah, Heidi, can you can start? Yeah.
Okay, no worries. Let me just share my screen.
Yeah.
Okay, so we can close down the last one and go and create a new blank one, because in this workshop, you see that we're now up to, for some reason it's labelled number 1, but should be number 10 anyway, but it's model builder, load builder, T-Rex. So we're going to build a model from scratch. So we're not just going to import the features like the pipes and the junctions. We're also going to use load builder to put demands in, and T-Rex is for terrain extraction. So terrain extraction using contour files or terrain models or whatever. So we're going to build this model from a brand new blank into a full model with different types of demands as well. So we're going to do the demands differently, a few different ways to compare them. All right, so let's get started. So got our blank model here, and then what we need to do is go straight to Model Builder. So over on the right of the Home tab here is Model Builder. And then once you're in Model Builder, go ahead and select New. The data source type that we want is Esri shapefiles. If you then browse, you'll find that Model Builder has its own folder here. So you want to go to Model Builder and select all 5. So once you've selected all 5, click Open. And if you click Show Preview, you can see the different types of information we have for each different type of element. Okay, so go ahead and click Next. And of course, we need to select meters. And I'm going to untick Create Nodes if none found at endpoint. And then Next. This one here, that's fine with the defaults. We'll come back to that later. So Next. And current scenario, we only have one scenario to base. Map elements by key field. Label we did yesterday. This time we're going to do GIS ID. So once you've selected GIS ID, you can click Next. And this is the important screen here. So this is where everything gets matched up with the shapefile and GIS property into the WaterGEMS property. So this is the most important one here. Okay, so firstly the junction. The key field is of course GIS ID to match up with the GIS ID. And then we need to also match up the label here. So label, and then the property here will be label. So something interesting to note here with the junction is that there's no elevation field. So the GIS does not have the elevation of these junctions. Okay, pipes. Of course, pipe and key field GIS ID. And D is for diameter. C for Hazen-Williams C. Label, of course. And material. I'll just give you a few moments to put those in.
Yes.
Okay.
Yeah.
Yep.
Okay. Yeah.
Pumps. So pump. Of course, you need to change the table type to pump. Key field GIS ID, of course. And you'll see that this one does have an elevation. So the pump does have an elevation on it. So the property there that we want is, of course, elevation. We also want the label. Okay, next one, reservoir.
Yes. Yes.
So reservoir there, GIS ID, of course, key field. The elevation is also on the reservoir, so we can grab the elevation property. And don't forget to do label. And then the last one, tank. So of course we want tank. or GIS ID. And then diameter, of course, is diameter. Base elevation, so this is going to be elevation brackets base, and then the label.
Yes.
Okay, so that's all of them done, all five. All five, along with all of the properties and fields. So next, we don't need to worry about snapshots. So next, and then would you like to build a model now? Yes, finish. So you'll find that if you go to the messages, you see that there's unable to create a bunch of these pipes because the start or the stop node could not be found. So we've got some errors here. So what we're going to do is go ahead and fix that. So if you close that down, and then what we want to do is go to the model builder that you just created there. So in my case, it's model builder 16. Yours will be different. And then go to the duplicate button. So now mine is model builder 17. Okay, once you've created the duplicate, double click to edit it. Of course, this is all filled in already, so we can just click next. And this is where we want to click establish connectivity using spatial data. And I'm going to change this to 0.03. So 0.03 meters.
Yep.
And then next, 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 all the way until you get to, would you like to build a model now? And then you need to change it to yes. So what we're doing is we're rebuilding the model.
Yeah.
And then finish. This time you see that we now have no red error message. So if you close down the model builder summary and then close down model builder, it says, would you like to synchronize the drawing? Yes. Once you've synchronized it, you can use the zoom extents to find your network.
Yes.
Okay.
Yes. Okay. Yes.
So we need to review and find any errors. So first thing we need to do is I'm just going to go to our flex tables here and open up the pipe table. And this is just to have a look. So you can see here, if we look at the diameter, you can see the diameters are all different, which means that our mapping of our pipes properties from the shapefile has matched up with the diameter field in WaterGEMS here. So that means that that's come in correctly. So we just wanted to check to make sure. So you can close down the pipe flex table. Now what we need to do is look for some errors. And so to do that, we need to go to the View tab. And then within View, you'll find in the Selection and Query area, Navigator. And Navigator is essentially a tool that finds errors for you. It's like an error checker or an error fixer. So what we want to do is go to the little arrow next to current selection here, and we want network review, nodes in close proximity. And the tolerance that we want is 1 meter. So if you OK that, we didn't get any.
Yeah.
Oh, that's good.
Yes.
Okay. All right, so let's close that down and go back to Model Builder. So back to Home and Model Builder. And then go back to Model Builder 17. And then double click on Model Builder 17 or whatever yours is called, and then go next, next, and then we want to re-tick this. So you're going to tick remove objects from destination if missing from source.
Yeah.
Okay. And then you can just go next, 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 next. Would you like to build a model now? No. And then finish. So what we can do now is go over here. It says sync out. And we want to click sync out. And it will modify it. Yep. Continue.
Yep.
Okay, so we can close that down again. We're going to go back to our network navigator and see if we have any problems. So view, navigator, and this time this is network review again, this time orphan nodes. Again, none. Okay, so back to the Home tab and just check your flex table for this time junction. Just open up the junction table and of course you'll find here a very empty elevation column. That's what we're about to fix. So close that down and we need to go over to the background layers tab. So in the background layers, new file. If you go back to starter, you'll find that T-Rex has its own folder. You go ahead and open up T-Rex and you'll find DEM elevation points. So when you open this up, you'll find two problems. Firstly, the unit is in meters, but this file is actually in feet. So you need to change it to feet, because a lot of the time if you get it from Google or Google Earth, something like that, it will be in feet, which is fine because we tell it it's in feet and then it will convert it for us. Secondly, the line color. We don't want black. So I'm going to change it to green. Change it to any color you like. And then click OK. So you can see that the green T-Rex area covers most of the network. There are some areas out here that are outside the boundary, and out here as well, but that's fine. We can deal with that. So now what we're going to do is use this file to put the elevations in. So over to the Tools tab and T-Rex. Data source type, Esri shapefile. The file is the same one, DEM elevation points. Elevation field, DEM meet. As you know, it's in feet, so we're going to leave it in feet. And of course, it will convert it to meters for us. So we don't have to do anything manually. It's all done automatically by WaterGEMS. So next. 11 of the features are out, so you can see that they're out here. So, okay, there you can see your preview. Putting it into the base physical, which is correct. And then all you need to do is finish. Okay, so
Yes.
now, of course, we need to go back to home and check our flex tables to make sure that it worked. So, flex table junction. See that a lot of them have values in there, and what you might want to do is go to elevation and say sort ascending. So for all of the ones that don't have an elevation here, I'm just going to highlight them.
Tired of cold?
Right click, global edit. Set them all to 775.
Yes.
Okay, so if you close that down, and now we want to zoom in on this area down here, the pump. So if you zoom into the pump area, there you can see it there, and you can see that it gets very messy. So what we can do is go to the element symbology tab and change from CAD to GIS. So you can see that we can now see more clearly our pump station. So if you look at pump 1 here, it's initially on, and it's all sorted. So the pump definition here, if you go to pump definition and then edit pump definitions, create a new one, and then you'll need to enter some values here. So
Yeah. Okay. Yeah. Training. Yeah. Continue.
okay, so if you close that and then select the pump definition, and then go to pump 2 and change the status initial to off.
Yes.
And select the pump definition as the same one, pump definition 1.
Yes.
Okay, so close that down, and now we can get started on our demands. So demands are obviously very important because that's what's going to determine everything about how much water you're moving and where and when your pumps turn on and off and all that kind of stuff. So over on the background layers, I'm going to untick DEM elevation points. And then new file. So in the starter file, you see load builder, the load builder folder, and you can see there's several files in there, and the one that we want is meters SI. Go ahead and open that up, and again, this one is in meters, but you don't want it to be black. So let's change black to, I don't know, blue. and then OK.
Yeah, okay.
All right. So what we're going to do is firstly just check our demands. So if you go to the demand center, demand control center, you'll see that it's empty. So we haven't imported any demands with model builder, so we need to obviously use load builder. So all we need to do is just check that that's empty, and you can close. All right.
Yes.
So now we can use load builder. So back to the tools tab and load builder. Okay, so if you open up load builder, create a new one, and by the way, we're going to do several here. So it's important to note that the first couple of methods that we're going to use, and we're using point load data, area load, population, land use. These three up the top, the external data, these are the old way of doing it. So you can still use this method, but it's less accurate, and it's certainly harder to use and harder to track. So we're going to go through this exercise and show you how to do it. However, we will also go through the new method, which is the customer meters. So that's just something to note there, that the customer meter is the best way to do it. But in this workshop, I'm also going to show you how to do this method here. But if you can avoid it, then you shouldn't use these. You should use the customer meter load data if you have it available. So the reason we show you these ones is because you may not have customer meter data available. So, nearest node. Next. The node layer is junction all elements. Go ahead and select junction all elements. And in the billing meter layer, it's the same file, meters SI. And it's in meters, that's fine. So you can OK.
Yes.
And we want to go from load type field, we want none. We don't want a load type. Now, the usage field here is demand, and the unit is gallons per minute. And gallons per minute is correct. So the reason that it's in gallons per minute is just to show you that we can convert from any unit into our model. So it doesn't matter if you get any files in feet or in gallons or whatever. Model builder and load builder can handle it. So go ahead and click next. And we also want to put in a global multiplier here for leakage. And we're going to find leakage in the next workshop. But for this one, we're just going to add it. So it's 1.176.
Yeah.
And so that's going to add to the total.
Yeah.
And then next, see each demand for each node. And they're all fixed, but we can change that later. So that's fine. And then next. And the label here is near node 1.
Yes.
It's a new alternative called near node 1. And of course, the parent alternative is base demand. And finish. 105 loads exported. So close that down. Synchronize, yes. So you remember that we just created a new alternative. So of course we need a scenario to put that in. So over to the scenarios, and from base, a new child, which is going to be called load at node. If you open up load at node and then change your demand to the nearest node, and then make it current, of course, and then go back to your home tab and we'll check the demand control center. And of course now we have demands in our model.
Yeah.
Okay, so now we're going to do another different type of load build. So if you close that down, go back to Tools, go back to Load Builder, and create another new one. And so this time, instead of nearest node, you can see we've also got billing meter aggregation and nearest pipe. So nearest pipe is the one that we want. So next, pipe layer, same thing, pipe all elements. Node layer, junction, all elements. Billing meter layer, and of course it's meters SI. And the demand type, none, demand, gallons per minute. So it's all the same, except that we're using pipe instead of junction. So next, 1.176. So you can see the demand is exactly the same. And next, next, and this one, of course, is called nearest pipe. And it's a new alternative from base demand.
Yeah.
And finish. So you see that it's very, very similar, but just different method. So if you wanted to compare them, of course you can synchronize. From base, new child, and this one's called load at pipe. And if you open up that, change your demand to nearest pipe. You make that current and go to your demand control center, you'll find that it's very similar, but also different. So slight difference, but you still get the same total amount of demand. And that's just a personal choice about how you want to do it.
Yeah.
Okay, so the next one is a little bit more complicated. So the next one, if we go to the tools menu, what we're going to do is we're going to create some polygons first, and then we're going to use the polygons to assign the demands. So they're going to be called Thiessen polygons, and WaterGEMS will create those for us. So up in the load builder model creation area, you'll find a Thiessen polygon. Go ahead and open up that. The node layer that we want is junction all elements. It's fine. Next, that's fine. Next, and then output file. So if you click the ellipsis there, and I'm going to call these Dean's polygons.
Yeah.
Save and finish. So now we need to figure out what that actually did. So down to the background layers, turn off meters, and of course new file, and go and find your polygons. So open up polygons, of course change the line color because you do not want black. I'm going to go with orange. Okay, so I'm going to go back to element symbology and go from CAD back to CAD style. Now, if you zoom in, you'll find that each polygon contains one junction. So one junction per polygon, and everything that's inside the polygon belongs to that junction. Okay, so now what we can do is use that as a basis for our next load builder. So back to Tools, Load Builder, and create a new one. And what we want is population land use. And load estimation by population. You can see that it's got the polygon in the picture. So next, service area layer. It is, of course, the polygons that you just created. The population layer, you go in there, you'll see that we've got a population census here. So the population type field is type. The density field is density. And it's in population per hectare. So load per capita per day for R1, residential 1, 371. Residential 2 is 310. And for commercial, 76. So next, global multiplier 1.176. Next, and see the demands here. Next, and this one's going to be land use. New alternative, of course. And finish. So you can synchronize that if you want. Back to the scenarios, and from base we'll take a new child. It's called load by land use. And open it up. Change your demand to land use. And if you want to make it current, you can, of course, check your demands.
Yes.
Okay, so Quan, I'm just checking the notes here. The notes you sent out don't have the next step in it.
Yeah.
So you might just have to follow along without notes for the next couple of minutes.
Okay. Yeah, I will summary for SAWACO.
Sure.
Dạ. Chào mọi người ạ. Mình sẽ xin phép summary lại những cái tiến trình mà bạn Điên vừa làm cho đến bước này. Thì với cái bước này thì bạn Điên khai thác việc khả năng là chúng ta sẽ add những dữ liệu từ sharp file, thì trong đó có bao gồm một chút về git. Thì bằng cách sử dụng những cái dữ liệu đó và add vào WaterGEMS, và tiếp tục chúng ta sẽ sử dụng một số cái lệnh như là load binder để chúng ta sẽ gán những cái dữ liệu mà chúng ta đầu vào của chúng ta sẽ gán và chúng ta liên kết nó lại với mô hình. Thì giống như là ở đây thì chúng ta sẽ liên kết với chúng ta sẽ sử dụng 3 kịch bản. Thứ nhất là chúng ta liên kết cái công tơ sử dụng nước ở hộ gia đình ở khu dân cư đó, chúng ta sẽ liên kết với những cái node gần nhất. Thứ hai là sử dụng cái phương pháp đó là liên kết những cái công tơ nước với lại những cái file gần nhất. Và thứ ba là sử dụng cái liên kết đó là sẽ load trên cái phân bổ của cái mô hình polygon, tức là mô hình phân bổ dân cư. Thì ở đây Dean đã demo cho chúng ta là 3 cái phương pháp khác nhau. Và chúng ta sẽ sau khi mà sử dụng 3 phương pháp đó thì chúng ta sẽ có 3 cái kết quả gần tương tự nhau, nhưng mà tuy nhiên thì không có cái tức là nhìn thì nó tương tự nhau thôi, nhưng mà thật ra thì mỗi phương pháp nó sẽ cho ra một cái số chính xác khác nhau. Thì Dean có nói rằng nó là tùy theo cái nhu cầu và cái mức độ mà cần, tức là tùy theo cái thiết kế hệ thống của chúng ta, tùy theo cái quy mô mà chúng ta có thể set cái kịch bản đó tương ứng. Dạ, Cindy, dạ, we're done. Dạ. Ok. Tới bước này thì mọi người có câu hỏi nào không ạ? Thì cái nội dung chính trong cái bài này đó là chúng ta sẽ thấy được cái cách mà WaterGEMS có thể load được những cái dữ liệu bên ngoài vào. Thì điều này cũng rất là quan trọng, bởi vì đối với những cái mô hình lớn hoặc là rất lớn đi thì chúng ta không thể nào mà thiết kế thủ công, chúng ta không thể nào mà zoom lên mà view từng cái node hoặc từng cái file hoặc là từng cái công tơ được, mà chúng ta phải dùng những cái lệnh mà hỗ trợ tự động của WaterGEMS để làm những cái việc đó. Thì đây là một cái mô hình cũng tương đối nhỏ thôi, nhưng mà chúng ta có thể tưởng tượng là mở rộng ra là cả một thành phố hoặc là cả một quận, thì cái việc mà xử lý nó rất là lớn và không thể nào làm thủ công được. Hi everyone. Mọi người gần SAWACO có câu hỏi nào không ạ?
So, Quan, there's just a couple of minutes left to finish off this workshop.
Yeah, okay, please continue. No, yeah, we have a question from Mr. Nguyễn, SAWACO.
Sure.
Yeah. Okay, we translate.
So continue, Quan.
We have a question from Mr. Nguyễn.
Sure. What's the question?
Yeah. I typing in chat box.
Oh.
Okay.
Oh, how to assign demand value when there is an Excel file? Sure. Yeah. That's through Model Builder. So I'll show you how to do that right now. So we'll do that in the software now, Quan.
Yeah, that's right. Yeah, you can show it. Yeah.
If we turn off the polygons, just go back to our model.
Yeah.
And then go back to Model Builder.
Yeah.
Create a new one.
Yes.
And you see from the drop-down list here, there's Excel. Now, in this example, I only have a shapefile, but it works exactly the same way with Excel. So select shapefile, but it could just as easily be Excel.
Yeah, okay. Yeah.
Browse.
Yeah, okay. I will change this for SAWACO. Dạ, chào anh Nguyễn ạ. Thì bản Dean nói là hoàn toàn có thể sử dụng được file Excel để import vào trong mô hình bằng cách sử dụng lệnh Model Builder. Thì cái lệnh Model Builder này sẽ import được file Excel, và cái cách mà setup sau khi import vào thì nó cũng tương tự như chúng ta làm với set file lúc nãy. thì cũng là sau đó chúng ta cũng là chọn file Excel để import, và chúng ta sẽ ánh xạ những cái giá trị, những cái cột trong file Excel đó tương ứng với lại cái tham số nào trong WaterGEMS. Thì cái việc ánh xạ đó thì nó hoàn toàn giống như lại cái việc xử lý với lại cái shape file lúc nãy. Rồi, anh Nguyễn ok với câu trả lời của bạn Đinh chưa? Dạ, thank you, Mr. Nguyễn thank for you. Yeah.
Okay. So
Okay. Yes.
Shapefiles, browse, and then meters SI again.
Yeah.
And then if you show preview, you see there's a demand column. So exactly the same as if it was an Excel sheet.
Yeah. Yeah. That very. Yeah. Like Excel. Yeah.
Yeah.
Okay.
Next,
Yeah.
and then meters. And then all we need to do is go here and say customer meter. Key field label and label. And then all you need to do is go to demand and then demand base.
Yes.
And then it's just a matter of next, next, finish. So see 5,443 customer meters. So if I close this down, you'll see that what's happened here is it's put in the houses, put them in as houses.
Yes, very right. Yeah. That's nice. Yeah.
So mine was a shapefile, but you could do exactly the same with Excel.
Yeah. That's okay. That's good. Thank you. Yeah.
So the last step is to assign each of these customer meters to the junction or the pipe.
Yeah.
So load builder, new, and this time customer meter. And we want nearest pipe, pipe layer, all pipes, and then distance weighted, and then junctions, all customer meters. And then I'm going to create taps and laterals for customer meters. So next, and customer meters, and I'm going to update my base demand. Finish. Okay. So this is what I was mentioning at the start, Quan. This is the new method of doing it. It's not in the workshop yet, but you can see that we can assign the houses via a lateral to a tap on the pipe. This is still one whole pipe. And then we can tell exactly where each demand is coming from on each pipe and each junction. So the customer meters are a very powerful tool.
Yeah, very powerful. Yeah.
So I don't know if you want to summarize that or whatever, but that's the end of the workshop for Model Builder, Load Builder, T-Rex.
Yeah. Yes, standing. Yeah. Okay. We okay. Now we have no more question from SAWACO.
Okay. Should we take a break and then we'll have one last workshop to go.
Yes, okay. Yeah. Chào mọi người ạ. Chúng ta hiện tại chúng ta đã xong cái bài này rồi và chúng ta sẽ nghỉ giải lao thêm 15 phút nữa. Và chúng ta hẹn gặp lại mọi người vào lúc 12:25. Yeah, thank you. Yeah, please take a break.
Called leakage detection start. So what we're going to do here is we're going to take an existing model and we're going to compare the inflow from the reservoir from a flow meter to the model. And then what we're going to do is basically calibrate it via a leak detection so that we can increase the flows to match the flow meter in the model.
Yes.
So you'll see that as soon as you open up this model, we've got these larger highlighted junctions. So if we go to the element symbology tab, you'll see that we've got this observed pressure color coding here. So what it's saying is we have a pressure transducer on each of these enlarged green junctions here. So these are the locations of our pressure transmitters. What I'm going to do is I'm going to untick that, and I'm going to tick emitter coefficient. You see that ticking emitter coefficient didn't do anything because we haven't actually done anything as far as finding the leaks yet. When we do find the leaks, of course, they will appear here in our drawing. So if you go up to the reservoir here and zoom in, you see that there's of course a pipe coming out of the reservoir, and if you double click, you'll see that that's pipe 872. So pipe 872, and what I'm going to do is I'm just going to right click on pipe 872 and say, firstly we need to compute our model. So if you go to the base and compute, and then you can go to graph. See that pipe 872 is being graphed for flow, and that's correct, so you can tick OK. And here you can see the model graph of that pipe. So this is what the model says that pipe should be doing. And what we're going to do is we're going to compare that to what the flow meter says. So to do that, if you come up to the options here, and then under the options you'll find observed data. So go ahead and open up observed data. Okay, so you go new, and you can see observed data 1. I'm going to rename that observed inflows, observed inflow P 872.
Yes.
So of course we need something to paste into this this area over here, and so to do that, open up the folder in which you have the solution and starter and all of the PDFs. And if you go into the starter folder within there and scroll, you'll find that there's field data for comparisons. That's an Excel sheet. So go ahead and open up in Excel field data for comparisons. So you can see that in our Excel sheet here, we have observed inflows for P872. What we need to do is highlight both the time and the observed inflows, and then go all the way to the bottom, down to 24 hours. And then what you want to do is press Control-C to copy those two rows, and then go back to WaterGEMS. What we need to do is paste those two columns into these two columns here. So I'm going to use Control-V to paste in the Excel data that we just looked at.
Yeah, that's okay. Yeah.
Excellent. So once you've done that, close it down, and of course you now get this red dot graph, as well as our observed our modelled flow. You see that the flow meter data there, which is the red one, is of course much higher than the modelled one, which means that we very likely have leakage that we're not accounting for, which is why this flow is higher than this flow. So the first thing we need to do is save this graph. So I'm going to go to Add to Graph Manager and save it as Inflow Comparison. Of course, we've now saved this, so we can come back to this graph anytime we like. So once you've saved it, you can close it, because we need to go and fix our modelled flow, of course. Okay, so what we need to do is fire up our calibration tool. So over to the Analysis tab, and under the Darwin folder, you'll find Darwin Calibrator. So the interesting thing about Darwin Calibrator here is you can see that it already has all of these field data snapshots recorded, and you can see all of these values have been entered in for us. So the way that that's being done is via this button here. So import field data from SCADA. So we're not going to do a SCADA Connect or a SCADA workshop in this particular training. We do have 3 SCADA workshops in the full training, but if you connect to your SCADA system or through a third party like Excel or a database something, then you can produce all of this information just by clicking the import field data from SCADA. But as you can see, all of our data is already in for us, so we don't need to do that. What we need to do is set it up to run. So what we're going to do is go ahead and create a demand group. So over to the demand group tab, and create a new one, new demand group 4. I'm going to rename that leak detection group. Once you've renamed it leak detection group, go into the element IDs here and click the ellipsis, and then you'll get the one at the top, select from drawing. Go ahead and select from drawing, and I'm just going to draw a big box around the whole thing. So as you can see, I've selected every single element, every junction within the model, and then green tick. And okay, so now 701 junctions in our model. So we've got our demand group, we've got all of our field data. Now we can go and create an optimized run. So from leakage study 1, we'll say new optimized run. Now I'm going to rename that, and this is going to be called leak detection at 3.25. Okay, so over to the demand tab, and this is where we need to tell it what we're doing. So you can see the operation here is multiply original demand. That's not what we want. We want to change that to detect leakage node. Once you change it to detect leakage node, you'll see there's a minimum here, which is 0, that's fine. The maximum, we want to set that to 0.5 with an increment of 0.01. And the number of leakage nodes, which is the maximum allowable, is 10. Okay, so now a very important step. We need to go to the field data tab. You see all the field data we've got here is all ticked on, it's all active. We don't want to use all of that because we don't have all day. This is a time-sensitive workshop. So what we need to do is go up to is active and global edit. And I'm going to set it to unticked. So basically, untick them all. Then what we need to do is scroll down until we find 3.25. Go ahead and tick on 3.25. Okay, once you've ticked that on, you can click compute. See that we're running 10,000 trials. And there's some fitness, and as it goes down, as you can see, and then eventually, of course, it's going to finish the 10,000 trials. And you'll notice how long it took to go through 10,000 trials there, even though we've only got one ticked on. So you can imagine if we had all 96 turned on, how long that would have taken. So if you close that, and then over on the left, go to the solutions, see that it's got a fitness here of 0.2.
Yeah. Yes.
Okay, so if we go to solution 1, see over on the right-hand side here, we've got the adjusted emitter coefficient. I'm going to go and right-click, sort that descending. And so you'll see that there's 6 leakage nodes here that have varying emitter coefficients.
Yes.
Okay, so before we do anything with that, because we ran out of trials, what we're going to do is run it again, but this time with more trials, so that we get a more accurate result. So if you go and back up to leakage detection at 3.25, and then new optimized run, and this one's called leak detection at 3.25 more trials.
Yeah.
So with that done, you can see that we've still only got the one ticked, but we need to go to the options tab. And the maximum trials here from 10,000, we want 20,000. Solutions to keep, 3. Population size, 100. Once you've done that, compute. You can see that our fitness is already better. Okay, so if you check your solutions, see that solution 1 has the best fitness, of course. And if you check, if you highlight solution 1 here, what we can do is we can export it so we can check it in our drawing. So we can actually see where our leakage nodes are. And that's what we're going to do. So with solution 1 highlighted, come up to the top to the export to scenario button. Export to scenario. The export scenario there, you can see the name of it. Export emitter coefficient, we're going to want to tick that. Untick export demands. And so all we want ticked is the scenario and the emitter coefficients. And you'll find that over here, we're about to add a new scenario. So click OK, and there it is. And then you can close down Darwin Calibrator. Okay, so the first thing you want to do, of course, is go to your new scenario here and make it current. As soon as you do that, you'll see that we've now highlighted our leak spots. So this is where Darwin Calibrator has determined that we've got leaks. But the main thing we want to check as well as where the leaks are is if those leaks have resulted in a better calibrated model. So I'm going to click compute. We need results, of course.
Yeah.
And then close down your summary here and open up your graphs. Of course, we've got the inflow comparison graph here that we created earlier. So open that up and you'll see that it looks exactly the same. What we're going to do is we're going to modify it. So come up to the series options again and open up the graph series options. And as you can see, we've got the leak detection at 3.25. You want to tick that on. So we're going to put both the base and the leak detection scenario on, as well as the observed flow meter inflow. So we'll have 3 graphs here. As you can see, we've lifted up our modelled flow to be much closer to the flow meter data as is. However, you can see that we've still got significant differences here at certain points during the day. For example, 10 hours here is quite a big difference, and down here at 18 hours, there's quite a large difference between the model and the flow meter. So we're going to try again. We're going to add an extra time step in. So if you close down the graph and go back to your Darwin calibrator. All right, so from leakage detection at 3.25 more trials, I'm going to take a new optimized run. This one is called leak detection at 3.25 plus 10.
Yes.
Go over to the field data and find hour 10 and tick it on.
Yes.
Compute it. So you'll notice how much slower the trials are going now that we've ticked 2 instead of 1. And so you can probably understand why we didn't want all 90 of them ticked on all at the same time.
Yeah, very long time.
Yes, but
Yeah.
most of our users, when they do a calibration or a leak detection, that they will run it overnight. So when they leave the office, they click start, and then they come in the morning and it's finished.
Oh, wow, overnight, yes.
Yeah. You got to make sure no one turns your computer off.
Yeah. Yes, that's right.
Okay. So of course you can check your fitness. The fitness is worse because we have twice as much data. And if you check the solution, see that we've found 4 leakage nodes. And we're going to do the exact same thing again. So with solution 1, I'm going to export it. The scenario, the emitter coefficients, turn off the demands. So it's just the emitter and the scenario. And then, okay. Close it down. There you can see your new one. And as soon as you make it current, you'll see that your leakage spots have changed slightly. And now we want to compute it. Okay, once you've computed it, we can check it on the graph. So back to graph, back to the inflow comparison.
Yes.
And back to the series options to add 3.25 plus 10. you'd see that now at hour 10, it is perfectly aligned, but we've lost some other resolution around it. So, of course, the more data you add, the more accurate it gets, but the longer it takes, then we don't have enough time to add enough information in here to get this correct.
Yeah.
So, is there any questions on that? Because that is the end of the leak detection workshop.
Yeah, that's a summary for SAWACO.
Sure.
Dạ, chào mọi người ạ. Mình xin tóm tắt lại cái bài tập của Dean vừa thực hiện. Thì với bài tập này Dean đã import một cái mô hình mạng nước vào, và cái mục tiêu đề ra của bài tập đó là sẽ phát hiện những cái điểm mà có nguy cơ rò rỉ nước, tức là bị thất thoát nước ở trong cái mô hình. Thì với cái mô hình này thì Dean đã kết hợp thứ nhất là mô hình, thứ hai đó là những cái dữ liệu quan sát thực địa tại cái đường ống đầu vào của cái mô hình, thì so sánh với lại cái lượng nước đổ vào đầu vào và cái lượng nước đo đại tại thực địa, thì sẽ phát hiện ra là chúng ta sẽ có những cái sai lệch, và cái sai lệch đó thì thường là sẽ do rò rỉ. Thì sau khi mà chạy cái mô hình của Darwin để phân tích thì theo hai kịch bản khác nhau thì Dean thì nhận thấy là chúng ta có 6 cái điểm có nguy cơ rò rỉ, và sau khi chạy phân tích thì chúng ta thấy là khi mà áp dụng những cái mà mô hình Darwin vào thì cái dữ liệu cho ra sau khi chạy phân tích nó sẽ gần sát với lại cái dữ liệu quan sát thực tế. Thì từ đó chúng ta có thể là khoanh vùng, và chúng ta bắt đầu là chúng ta đi tìm hiểu cụ thể hơn, chúng ta có thể khảo sát xem là rò rỉ ở cái nào và chúng ta có thể khắc phục cách dễ dàng hơn. Thì đó là một tính năng khá là mạnh của WaterGEMS. Thì với cái tính năng này thì rất là hữu ích cho những cái công việc như là phát hiện rò rỉ và chúng ta sẽ khắc phục đường ống. Từ đó chúng ta có thể là tăng cái hiệu quả, tức là tăng cái hiệu quả của đường ống, và chúng ta giảm chi phí thất thoát. Thì thông thường những cái chi phí thất thoát này trong một cái hệ thống nước thì cũng tương đối là lớn. Dạ. Thì nếu mà mở rộng ra cái mô hình này, nếu mà lớn hơn nữa thì cái việc thất thoát sẽ rất là nhiều, và cái việc tìm kiếm những cái điểm thất thoát đó thì thường sẽ không dễ. Thì với WaterGEMS thì chúng ta sẽ có những cái gợi ý từ phần mềm, từ đó chúng ta sẽ khoanh vùng và sửa chữa đường ống tốt hơn. Vừa rồi thì Dean đã hoàn thành cái bài tập này. Thì Dean muốn hỏi mọi người là có bất kỳ cái câu hỏi nào liên quan không, và Dean sẽ sẵn sàng giải đáp. Nếu mọi người có câu hỏi thì vui lòng nhập giúp em vào chat box. Mọi người có câu hỏi nào không ạ?
Any questions? Fun?
Yeah, I think we have no question from SAWACO.
Okay.
Okay.
Yeah. So that's all of the that's all of the workshops done. And if there's any questions on anything at all, I'm happy to stay and take any questions, or anything else that they'd like to know.
Yes. If anyone have a question.
Yes.
Yeah.
So, Kwan, if they have any questions, my suggestion here is you may share your email ID let them send it to you and you send it to us so that we'll communicate back to them
Yeah,
any technical questions to them.
that's right.
Yes.
Yeah, that's okay. Yeah.
Yeah.
Yeah. Nếu mọi người có câu hỏi nào thêm thì có thể gửi cho em qua email hoặc là qua Zalo chat, thì em có thể forward những câu hỏi của mọi người đến Mr. Sinis and Mr. Dean, và hai bạn có thể giúp mình giải đáp những cái câu hỏi mà mọi người cần thắc mắc. Yeah, thank Dean, thank Sinis. If any question from SAWACO, Miket will forward to you.
Please, we'll be happy to answer.
Yeah,
Yes,
yeah.
please.
Thank you very much, Quan, and thank you everybody for coming for the last 2 days.
Yeah, thank you, Dean. Thank you, Sinis. Thank you very much.
Thank you,
No,
Imankat.
no worries.
Yeah. Bye. Bye.
Bye, guys.
Yeah, bye, guys.